So today we are going to discuss big data projects. Let's go through the first learning outcome statement. Identify and explain steps in a data analysis project. So there are two types of big data. One is structured data and one is unstructured data. The structured data is the data that you can get in the form of tables, like the financial data of a company, right? And anything that is in a structured form, in the format of tables, or in, you can say, the key pair relations. Okay, the unstructured data is like the textual data, the data that you collect from the internet, the data that is given in the images, or like the data collected from the social networks, that comes in the unstructured data part. Now there are some specific characteristics of big data. The first, let's see, the 3 V's of big data, it's called. These 3 V's are volume, velocity and variety. So any kind of big data is like the volume, it's a like the volume is huge here, like the trillions of bytes, or the trillions of bytes of data. Okay, and then the velocity is like the speed at which this data is being created. So if you go to the Facebook, like in you can say, like in any minute, billions of bytes of data is being generated, right? So that is the velocity of big data, like the velocity is very high. And then comes the variety means like the types of data that you can get in structured as well as unstructured data. The variety of big data is like, it's very wide, it's very broad, right? You can get multiple types of data. For the unstructured data, there is also a 4th V called the veracity. Now the veracity refers to the reliability of the data source, because the unstructured data is like the data collected from the social networks, the sentiment data, or the data collected from different blogs. So the reliability of the data source also matters in terms of unstructured data. Let's go through the steps in a data analysis project. The basic steps are the same, just the terminology is different and their basic function differs because they both handle the different types of data. First, let's go through the structured data. The structured first is the conceptualization part. In this step, you conceptualize the overall problem, like you determine what the output should be, and what kind of data do you need, who is going to use this, and things like that, right? In the data collection data collection step, you collect the data from the different sources. Okay, in the data preparation and wrangling step, this is like the taking the data and then preparing it and pre-processing the data to be used in model training. Once you prepare and wrangle the data, you come to the data exploration part. In this exploration, you analyze the data and you see whether you want to use this particular data or not. Okay, like suppose there are like multiple features of data, like you can say in a table there are multiple columns. Okay, so now you want to see that whether you want to use a particular column or not. That step comes in the data exploration part. After that, once you have explored the data, you have selected the relevant features that you require in your model. Then comes the model training part. In the model training, you provide that data to the model, you train that model and make it, and then it's like you validate the model, whether the model is providing the correct output or not. And once you are satisfied with your model, you send it to the deployment phase, you can say, like to the production phase. Okay, so now let's discuss the steps in the unstructured data analysis project. The overall steps are the same, but the terminology differs. Like in terms of conceptualization, now you call it a text problem formulation. In a text problem formulation, you formalize the problem, you define your null hypothesis and your alternate hypothesis regarding the problem, like what you are trying to define in the problem. Like whether you are going to check the sentiment data of a particular stock, right, the sentiment of the public, or you want to like find out whether a particular fund is winning fund or not, right, things like that. Once you formalize your problem, you come to the data curation part. The data curation is same as data collection, right? In the data curation, what you do is you use special programs like web spidering or crawling program to collect the unstructured data from the internet. Now, in the text preparation and wrangling part, the data that you collected here is pre-processed to be used in your model. By pre-processing, I mean this is a unstructured data that you collected. Now you need to pre-process it, do some calculations, or do some operations on the data so that the data could be used in a well-defined machine learning model. In the text exploration part, it is basically same as the data exploration that we discussed here. In the text exploration, you analyze the data and you see whether you want to use a particular feature or not. Like basically in the unstructured data, what you do is you like divide the data in terms of tokens or words. Okay, so in the text exploration part, you analyze whether these particular tokens are useful in your model or not. If those models are those tokens are useful in your model, you retain those tokens. But if those tokens are not being used in your model, right, you just discard them. And then comes the model training part. It is same that we discussed here. In the model training, you provide your data that you collected and pre-processed to the model. Now you train that model to be used in the deployment phase. Once you are like after training, what you do is you like calculate the performance of the model, and if you are satisfied with the performance, you push it to the production phase. Otherwise you push it to the production phase. Otherwise you have to retrain your model, do some operations on the data itself, and then the process just keep going on. Now let's discuss the objectives, steps and examples of preparing and wrangling data. See, I have divided the slide into two parts. In the left side, we will discuss the steps in the structured data. In the right side, we will discuss the steps of unstructured data. So the overall basically you can say the preparing and wrangling data involves the cleansing and organizing raw data into a consolidated format so that you can use this data into your machine learning model. For structured data, in the data preparation and cleansing part, you check whether these particular problems exist in the data or not, right? The problems could be like incompleteness error that the data is incomplete, invalidity error that data is not valid, inaccuracy error like the data is not accurate, inconsistency error that you have got the data but one feature says something else, the other feature says something else. Like suppose there are two columns, one is the age column and one is the date of birth column. In the date of birth column, you are given the date of birth in the year 2000, but in the age column you are given the age as 30 years. Now you know that 2023 is going on, so the age should be 23, but the age column says 30 years and date of birth column says the year of birth to be 2000. So these both datas are inconsistent with each other. That is called as inconsistency error. Non-uniformity error is, it's like the data is provided to you but the data in one particular column is not uniform. For example, let's say the date of birth column, in one row you are given the date of birth like this, in the other column you are given the date of birth like 4th June 95. In one another column you are given the date of birth like 0406, right? So the data is not uniform. The data is present but the structure in the structure of the data in different rows varies. Then comes the duplication error. Duplication error is like the same data is present multiple times. So in the data preparation and cleansing part, you will have to get rid of these these problems, like these errors in the data. So after only you remove these errors, the data will be used by machine learning model. The data pre-processing part, you extract the features. Extraction means like you are given one particular column, like you are given the date of birth, but you want the age. So you use the date of birth column to extract the age of particular person. So that comes in the extraction part. Aggregation means like you combine 2 or 3 features to define a new feature. Filtration means to filter the particular features that you want. And conversion means like if you are converting one particular feature to another. Now there are some particular terms that those are used here. First is trimming. In trimming, what you do is you remove the outliers. You completely discard the rows which contain the outliers. Like if I can say, like all of your data is for the people who are between 20 to 30 years of age, but there is one particular row which says the age to be 65 years. So that is like an outlier in your data. So you will remove that data completely, right? That is called as trimming. Another term that is similar to trimming is vinsorization. Now in vinsorization, what you do is you replace the outliers with minimum and maximum value, right? Now suppose let's go back to our example that we were discussing the age factor here. All of your data is between the years of 20 and 30 years of age, and so the minimum age that you have is 20 years, the maximum age that you have is 30 years. There is one particular data which says the age to be 65 years. Now instead of removing that particular row of data as we did in trimming, what we will do is we will replace the age of that particular person with the maximum age, because it is an outlier that is above your max value, right? So we will replace the outlier with the maximum value. That is called as vinsorization. That is, you kind of bound the data in 2 boundaries. You bound the data in 2 boundaries, the lower boundary and the high value boundary. That is called as vinsorization. Now comes the concept of scaling. Now see, to compare the particular values with each other, you have to perform scaling on the data. 2 types of scaling can be used. First is normalization, second is standardization. This is the formula to calculate the normalized values. The normalized values are useful because instead of handling with very large values, like suppose you have got data in terms of billions or millions, so instead of handling with millions and billions, you will get a normalized value which will lie between 0 and 1. Your normalized value will lie between 0 and 1. And then comes the standardization. Standardization is to be used. Standardization is to be used if you know that your particular data is in a normal distribution. If your data is normally distributed, you can use standardization instead of normalization. So that is the preparation and pre-processing part of structured data. Now let's come to the unstructured data. In unstructured data, you know that the data that you collected is coming from the internet, right? It's a raw data coming from the internet. So it will contain different type of tags. First of all, the HTML tags. We don't want the HTML tags in our data, so we remove the HTML tags. Then we remove punctuations like comma, dots, different type of punctuations. But there are some punctuations which are retained. How they are retained, I'll tell you. Like suppose you are given an amount in terms of dollars, right? You are given $1, 2, 3. So how you will kind of remove, you need to remove this data, but what you will do is you will add $sign just to retain the meaning of the data. You will have to replace dollar with this tag. Then 1, 2, 3 is a number, right? So you will replace it with slash number. Okay, and then you also need to remove the extra white spaces so that the data is kind of in a structured format. So after you have prepared your data, you have cleansed your data, then comes the text pre-processing part. In text pre-processing part, first of all, what you do is you perform tokenization. What is tokenization? Tokenization is like I write a sentence, I want to go to school, right? So these different words are like different tokens. I is a different token, want is a different token, 2 is repeated, so 2 will be counted as one token with the frequency of 2. This is one token, this is one token. So this is the step that you perform at tokenization step. Then comes the normalization. Normalization is like you normalize, because see, the I could be present in this format or I could be present in this format in your particular data. So you have to perform the normalization, because this and this are specifically the same, but the only difference between these two is the casing of the data. This is in a lower case, this is in an upper case. So you have to perform the lower casing of data. The stop words. Stop words are like these: to, am, was, were. So you remove these stop words. The stemming and lemmatization. Stemming is like you are given two words. Suppose stemming and lemmatization. I will tell you what is this. First of all, the difference between stemming and lemmatization is you have to, like, you are reducing the words, number of words in your token, in your bag of tokens, you can say. And how you are doing that? Suppose you are given two words, analyzing and analyze, right? So now both of the analyzed, you can say, both of, you know that both of these words are basically the only difference between these two is in terms of the verb that is being used here, right? So the token is here in the stemming process. What will happen is stemming will reduce the word to analyze. So it's the same stem that is being used here. It is used with ing, it is used with ed here. So the stemming is what it does, it reduces the word, right, to a particular stem. The lemmatization part, what lemmatization does is it reduces the word to its morphological root. Now we know that this particular word does not have any meaning. It's an incorrect word in terms of English, right? What lemmatization does is lemmatization will reduce these two words into analyze. Now we know that the morphological root of analyzing and analyzed is analyze here. So it depends upon the lemmatization process, it depends upon the knowledge of the language that the computer has, and also it is computationally very expensive and advanced technology versus stemming. So after you perform these particular operations, what you get is you get a bag of words. A bag of words is a collection of tokens, collection of unique tokens. Okay, and the document term matrix, you can say is it's like a table. Document term matrix is a table where the columns represent the frequency of the data and the row represent the particular token and the column represent the how many times that data is present. Then comes the n-grams. N-grams is like combining 2 or 3 tokens together just to retain the information. Like suppose like the stock market today, if I use the tokens here like stock market, so the computer will determine stock to be a different token and market to be a different token. So the market could be anything, like you can say the vegetable market or anything. Like the market does not have any particular form of like meaning here, right? and the stock could be the stock of a company or anything like that. But if I define a 2 gram here, I combine these two tokens, stock, market, the whole meaning is changed, right? Instead of stock and market to be treated as different tokens, what I did is I combined these two tokens, stock underscore market. So this is a 2 gram because I have combined two tokens here. The n-grams are used because n-grams keep the semantics alive. They keep semantics alive. Now let's come to the data exploration and data exploration part and the method of extracting, selecting and engineering features. For the structured data, the different data analysis, data exploration tools that are used are like histograms, bar charts, density plots, because this is a particular type of the data is present in the terms of tables. So you can create these different type of charts and plots and see how your data is structured, like how your data is performing, what are the particular features of the data that you can use, right, to just to analyze the data, that which features are important, which features are not, which features are like useful to you, which features are not useful for you. The feature selection part is like once you analyze the data, you will know that the what are the significant features that retain the important information of the data set, right? And then you can select those features out of all the features present. Now the feature selection is different from dimensionality reduction. Dimensionality reduction is like combining 2 or 3 features together to come with a new feature which retains the information, right? But the feature selection is like selecting selecting one particular feature from the features that are already present. You are not kind of reducing a new feature out here. In the feature engineering part is you are like creating a more meaningful features. Like if you are given a date of birth data, but you want to use the age factor here, so you can engineer a new feature called age. So that is the part of feature engineering. Now for the unstructured data, the exploratory data analysis, it's like a you have got your bag of words, right? You know that how you go to your document term matrix, like how many times a particular term is being repeated in a particular sentence or particular document, right? So what you do is you can create a word cloud. Word cloud is like an exploratory data tool which provides you a visual inspection, like if a particular word is being repeated many times, it will be greater in size. The term that is like the term that which has lower frequency will be like in a you can say will be smaller in size. Okay, so that is like a word cloud. The feature selection part is like how to determine which features are important for your data and selecting those features. First of all, for each feature you will be given a mutual information. The mutual information is like the information that that particular term is providing to you to kind of classify the data, to analyze the data, right? The terms which have mutual information closer to one define that those features are unique, those features are useful to you. And there are some frequency measures that you can use to kind of like analyze the features, that the importance of the feature. First is the term frequency. Term frequency is the word count in sentence divided by the total words in that sentence. Word count means if you are checking the term frequency of like say stock, then the word count in sentence means how many times the particular word, how many times this stock word is repeating in the sentence divided by the total number of words in that particular sentence. That will be your term frequency. The document frequency says that how many documents contain this particular word. Like suppose you are given 10 documents, out of those only 5 documents contain the word stock, then the documents that contain this word will be 5 divided by the total number of documents, that is 10. So your document frequency will be 0.5. IDF is the log of inverse of document frequency. So the lower the document frequency, the higher will be IDF. The lower the document frequency, the higher will be IDF. So like the lower document frequency will mean that that particular word is repeating in lesser number of documents, and a higher IDF will mean the same thing because it's an inverse of document frequency. There is an important term called TF-IDF. Now TF-IDF is basically the term frequency at sentence level that I defined here times the IDF. Okay. Now see, if the TF-IDF, higher value of TF-IDF means that TF at sentence level is high and the IDF is also high. The IDF high means that number of documents which contain that particular word are low. So high TF-IDF value means the word repeats in few sentences. That means the word is frequently occurring in a lesser number of sentences. So that means it's a unique word. It occurs frequently but in a very small number of documents. So it's a unique word which is kind of, you can say, it is very useful for you to classify your documents. The documents which will contain this term are, you can kind of combine those documents together, and those documents will be different from others. So they will provide very good information to you. So they are unique words which are very important for you. The words which have TF-IDF, high TF-IDF values. Then comes the feature engineering part of unstructured data. Feature engineering is name entity recognition, like the terms that you have, like the tokens that you have, they will be analyzed and seen and will be checked if they kind of like refer to a particular entity. Suppose you are given a particular example like WHO comes in your sentence. Okay, WHO is a token, so it will be given a tag of organization. So things like that, like you find the particular tokens, and if they are like they belong to a unique thing all around the world, they will be given that entity name. Now let's come to the parts of speech. Parts of speech means you analyze the data and you see that this particular word is being used as a verb, as a noun, or as anything. Like it creates a list of the nouns, creates a list of the verbs that are being used in the word in your data. The parts of speech steps helps to analyze the data better. The next part is describing the steps and techniques in model training. First of all, to like we have to select a particular method of, you can say, machine learning model training. Okay, so that method depends upon the type of data that you have, whether you want to use a supervised or unsupervised learning, whether you have the labeled data or not, whether you have unstructured data or structured data. Then the type of data, like whether it is structured data or unstructured data. Then the size of data. If you can say you got two types of data. One is like, let's say you got the sentiment data, whether the stock will pay dividend or not. Now let's say the dividend paying companies are very less in number, whereas the non dividend paying companies are very high in number. So you have got a class imbalance here. The dividend paying companies are very low, but the non dividend paying companies are very high in number. So how you will handle this type of problem is, you will either undersample from the non dividend paying companies to make it comparable with the dividend paying companies, or you will oversample from the dividend paying companies to make it comparable with non dividend paying companies. So that's how you handle your class imbalance of data. Once you select a particular method, you perform the model training, then comes the performance evaluation part. Do you analyze the performance of your particular data? There are two types of analysis that you can perform. First is error analysis, second is receiver operating characteristic. The first, let's go to the error analysis part. Error analysis, you have got these particular methods here: accuracy, precision, recall, F1 score. Precision is, you can say, how, like, precision is how precise you were in your in your predictions. Okay, so what you do is, how many positive predictions that you made, that will be as true positive and false positive, because how many positive predictions did you make, these are here, true positive plus false positive. How many of those predictions were correct, true positive. So it's like a proportion of the correct predictions that you made, true positive divided by the total number of positive predictions that you made, that is your precision. Recall, you can say that how much you recall, like how many positive cases were actually present in the data, but how many did you recall. So that will become then true positive divided by the actual number of positive cases, true positive plus false negative. The cases that you categorized as negative, but those were false negative, those were actually positive. So that is your recall. Accuracy is like how many correct predictions did you make out of all predictions, like true positive plus true negative divided by all the number of predictions that you made. So now there's a fourth parameter called F1 score. F1 score is basically a harmonic mean of recall and precision. Here P refers to precision, R refers to recall. So it's basically a harmonic mean of recall and precision. F1 score is better used when there is a class imbalance. When you have got class imbalance with you in the data, then you can use F1 score to better analyze your performance. Then let's come to the next part. The next tool of performance evaluation is receiver operating characteristic. It's basically a curve curve of true positive rate versus false positive rate. So the steeper the curve, like the more convex the curve, the better your model. The more convex the curve, the more will be the area under the curve. In this case, the A model has more area under the curve. So the A more greater the area under the curve means better performance. So here the best model performance is shown by model A. The tuning part is like kind of trading off between overfitting and underfitting. If your model will be underfit, then you have performed a large regularization. Here the training error will be very high. The training error, you can also call it as a high bias error. Okay, but as you reduce your regularization, as the model is made fit, and the other extreme level is overfit model. In an overfit model, your training error will be very low. But your validation error will be very high. That is called as high variance error. Okay, so now there's a particular level of regularization that you want to achieve, that will achieve this level of error, the minimum level of error at this point, where the variance and bias error will be balanced and your overall error will be minimum. This is the level of optimal regularization. And how it is achieved? If you have got a regularization parameter in your model, in your training model, you will have to test with the different values of that hyperparameter. We can call it this hyperparameter as lambda. You will have to check your model performance with the different levels of lambda, and once you achieve that optimal performance, you can say that level of regularization is your desired level.